Hello, this is Mr. Aspel, and I'm going to try to explain dimensional analysis with 3 easy problems. The first problem states a German girl goes on vacation to the Yucatan in Mexico. The conversion rate of euros to Mexican pesos is exactly 0.77 euros for exactly 12.97 Mexican pesos. How many Mexican pesos will she have if she brought with her 1 million euros? So first I would write down my known, my unknown, and my conversion factors. Conversion factors are things that are equal to each other in the problem. So for example, there's a conversion factor where it says 0.77 euros is exactly 12.97 Mexican pesos. So that's one conversion factor that I'll write right here. Euros equals 12.97 pesos. Your known for this problem is any number that's by itself that is not equal to any other number. So in this case, there's one number left over, 1 million euros, and that we're going to write as our known. And our unknown is what we're looking for. In this case, the question asks, how many Mexican pesos will she have if she brought with her 1 million euros? So we're looking for how many Mexican pesos she'll have when she converts her money. So for my unknown, I'm going to write question mark pesos. That's what we're looking for. So to start every problem, for the dimensional analysis part of the problem, you want to use the information above, and you always start with your known. So for example, I know that we have, or she has, 1 million euros, and the next step is we got to find a conversion factor that has euros in it. Well, right here we have a conversion factor with euros in it, and so that matches our known, and the same conversion factor has pesos in it, and that matches the unit of our unknown. So now we're going to write our conversion factor next. We're going to multiply our known, the number of euros, by our conversion factor. And this conversion factor on the bottom, you're going to write 0.77 euros, and on top, the 12.97 pesos. Okay. The last step is to cancel units. So we're going to cancel the euros. We're left with the unit pesos. And the last thing we have to do is we have to multiply the million euros by the 12.97 pesos in the numerator. So that number will give us 12,970,000 pesos. But we need to divide it by the 0.77 on the bottom. So when we do that, we get 6,844,155 pesos. Now, if you look at the original numbers in the problem, the euros are with 2 significant figures, the pesos are with 4 significant figures. The 12.977, the euros with the 0.77 had 2, and the 1,000,000.00 euros had 9 significant figures. So the least amount of significant figures, when we did all our multiplying and dividing, had 2 significant figures. So your final answer should have 2 significant figures. So your final answer actually should be, you're going to round the 16,844,000 pesos. The 8 is going to round the 6 up to 7. So it's going to be 17 million pesos is your final answer. which you can also write as 1.7 times 10 to the 7th power pesos. This is sort of a fun problem. It says if you know 13.35 centimeters is equal to the height of exactly 9 Oreo cookies, and you know some other facts. For example, there's 100 centimeters in a meter, and there's 1,000 meters in a kilometer, and the distance from Earth to the moon is 384,403 kilometers. How many Oreo cookies could you stack between Earth and the moon? So first you want to write your known. I'm going to write K, and your conversion factors. I'm going to put CF for those, and your unknown. So remember, conversion factors are anything that's equal to each other. So you can say that 13.5 centimeters is equal to 9 Oreo cookies. 13.35 centimeters is equal to 9 cookies. And you know these other conversion factors. I'm just going to underline them in the problem. And so your known, the thing that's not equal to anything else, is 384,403 kilometers. That's the distance from the Earth to the moon. That's what your known is. And your unknown is you're trying to find out how many Oreo cookies you could stack up between the Earth and the moon. So I'm going to put question mark number of cookies. Okay. So first I'm going to write the known. And you can see it in the known, the unit is kilometers. So we need to find a conversion factor with kilometers, and that conversion factor is right here. So after writing the known, we're going to multiply by the conversion factor. We need kilometers in the denominator so that the units cancel. So we're going to use this exact same conversion factor. 1 kilometer is equal to 1,000 meters. And we are going to have kilometers cancel. So there are the kilometers canceled. And we're left, if we solve the problem right now, we'd have our answer in meters, but we want our answer in number of cookies. So we're going to keep going. So now we can see we have meters here, and we do have one conversion factor with for meters. We can convert meters to centimeters. Okay, why would we want to do that? Because eventually we're going to convert centimeters to Oreo cookies using this last conversion factor. So using the 1 meter equals 100 centimeters, we put meters at the bottom because we want meters to cancel, and we put the centimeters on top. So the meters cancels, and we're left with centimeters. And now we can write the last conversion factor. 13.35 centimeters is equal to the height of 9 Oreo cookies. And we're going to write the centimeters on the bottom because we want that unit to cancel with the unit on top. That's really important that our units cancel. We have 9 cookies on top. And these centimeter units on top and on the bottom are going to cancel out. So the only unit that's left is cookies, which is exactly what we want. That's our unknown. We're trying to find our number of cookies. So what we want to do now is plug in these numbers into our calculator. So we'd start with 384,403 kilometers. We're going to multiply that by 1,000. And then we're going to multiply that number by 100, and then we're going to multiply that number by 9. So if you want to, you could multiply all the numbers on top first. If you did that, you'd get a really big number, 34596270000. Now, you also need to divide that number by the numbers in the denominator. So if you divide it by 1, you get the same number. Divide it by 1 again, you get the same number. And then when you divide it by this 13.35, you get the number below. And this number is in cookies. So we should put that fact down. We have that final answer is in cookies. And if we wanted to figure out the significant figures, you would look up above and you'd say, okay, this number was measured, the 13.35 centimeters. This number was measured, the number of kilometers between the Earth and the Moon. The other numbers weren't measured. They were just like knowns or facts that 1 kilometer is equal to 1,000 meters. So you just use the two measured numbers. The one with the least amount of significant figures is the 13.35. That is 4 significant figures. So your final answer should have 4 significant figures. So there it is, your final answer down below. This last one's a density problem, but you can also use dimensional analysis on a density problem. It states, what is the volume of a piece of boron if the density of boron is 2.34 grams per centimeter cubed and the mass of the piece of boron is 14.8 grams? So there's a couple things we know. One, our known is 14.8 grams. You can actually use density as a conversion factor. So the density, why can you use it as a conversion factor? Because this density, you can state that for every 1 centimeter cubed of the object, it has a mass of 2.34 grams. So that's how you can use it as a conversion factor. And our unknown in this case is the volume of the piece of boron. So we're looking for the volume. What is the volume? Okay, so we're going to start with our known. We have 14.8 grams. If we multiply by our conversion factor, so that this is our conversion factor, we're going to put grams at the bottom to cancel grams, the 2.34 grams. And on the top, we are going to write the 1 centimeter. And that's pretty much it. So dimensional analysis, the grams are going to cancel, and you say 14.8 times 1 is 14.8. You divide it by 2.34, and you get 6.32 centimeters cubed. And that is a volume. Thanks for listening to this video. I hope this helps you study for dimensional analysis problems and study for the test. Thanks. Bye.